Hi, this is another demonstration video from Tech Aero Designs, and this one is all about the topic of the potential failure mode that some people have been discussing on Flying Giants recently, where they consider it a possibility that an electronic ignition system, a CDI module, might potentially fail internally, and as a result of that possibility, that possible failure, send high voltage back through the wiring into an IBEC, and therefore potentially get back into the radio system and cause damage to the components. So what we're going to do is basically show you two conditions here. One is going to be the normal operating condition, and then we're going to basically set up a short circuit condition. This is going to be basically taking the output of the high voltage part of the CDI circuit and sending it directly back to the positive to the input side, to the voltage input side of the CDI, which is where the IBEC is. So that's the scenario that people are concerned about, that somehow some short inside would send high voltage back on the plus lead into the IBEC, into the radio. Okay, so the first thing we're going to show, well, I'll explain the circuit just a little bit, and then we'll show normal operation, and then what happens with the short or with the failure mode. First thing I'm showing you here is that little green object there is just a quick little prototype circuit board. It's a very simple circuit. It's just the black thing in the middle, little black rectangle, is a TVS diode. Transient voltage suppressor is what TVS stands for, also known as an avalanche breakdown diode. And they're designed to basically start conducting. They're put into a circuit. They normally are reverse biased. They're off under normal DC voltage conditions for the normal operation of a circuit. But they're designed to suppress high voltage spikes that might come from like, a lightning hit nearby in your neighborhood, and protect your TV or something like that. In this case, we're going to use it to protect for the possibility of a failure inside of the CDI, and it's never going to let the voltage actually get to the level of a spark. In fact, it's not going to let it get any higher than about 8 volts. But it is connected to what would normally be a high voltage spark, and we'll show you how that works in a little bit. But it's basically in parallel with the power source to the CDI, as I think you can see there. It's basically like a little Y connector. If we trace that, that goes back to the IBEC, and the IBEC goes back to receiver, which is an AR7000. And by the way, we have a couple of servos connected to the rudder channel and the aileron channel, just to show you normal operation of the receiver while we're doing all this stuff. And there's a spectrum data monitor. We'll try to read that. It's a little difficult because the numbers are small. It's all being powered by a regulator connected to a 2-cell LiPo. And oh yeah, and by the way, a little circuit here is just a quick little breadboard. This is just a little free running timer that basically sends, it simulates an engine running. So it simulates the output of the Hall sensor on your engine, and that's just connected to the CDI to make it fire. So the first thing I'm going to do is basically show you kind of like the simulated engine running, with the alligator clip substituting as a spark plug. Okay, so first thing, let's get the radio turned on. Okay, all right, so now we'll turn on the receiver. Okay, so we've got the receiver going. And we got ailerons, that's working, and we got rudder working. And I have the IBEC is actually connected to the throttle channel, just to make it a little easier to see how I'm doing the control on and off. So down at idle is off, and above the middle is on. Okay, so there's the LED from the IBEC, so off and on. And you can hear that snapping noise, and that is because there's your simulated spark plug firing. I think you can see that pretty clearly. It makes a very noticeable noise because of the large air gap that it's jumping across. And but this is simulating a normal engine running condition. All right, so everything's totally fine with the radio. Just like normal. Got rudder servos, aileron servos. Everything's working just fine. Okay, and now the next thing we're going to do is basically show you what happens when we involve the CDI circuit getting attenuated, the output getting attenuated or clamped by this little circuit here. Okay, so I'll turn it off for just a moment so I can connect it, and we're going to directly, whoops, if I can just get it to go on there. Okay, there we go. So now we have the yellow alligator clip connected directly to the resistor. The air gap is still there, so a spark would still jump. And again, the yellow goes back to the TVS, the clamping circuit, which is to the red side or the positive DC side, which is normally 5.3 volts or so into the CDI. Except now the CDI is going to run normally. It's going to still try to generate that spark. And in fact, you're going to hear a very muffled noise every time it tries to fire, because not because there's any spark, but because there's basically it's the stress to the circuit inside the CDI as it tries to fire. It's basically getting directly shorted through the TVS circuit. So you're just hearing the components stressing in there. The type of energy that it's discharging each time actually causes a little bit of physical stress to the components, but normally it's drowned out by other things. Okay, so here we go. Basically, the radio never got turned off. All I did was turn the throttle down to turn off the IBEC, and let's just listen. And also watch. You don't see a spark anymore because it's basically getting suppressed. There's no more than about 8 volts getting built up every time it fires. You can hear it. Alright, and everything's on. And by the way, everything still works just great. Even though you have a CDI that's trying its best to send out about 20,000 volts across an air gap, it's not being allowed to because this TVS diode is just eating that for lunch. Okay, so rudder servo, aileron servo. Okay, so this is going to go for a little bit, and it's not like it's overheating or anything, even though it's a tiny little component and it's a short circuit. The energy is getting dissipated. The energy of this spark is getting dissipated almost completely inside the CDI. And again, that's the stress that causes the clicking noise. This diode is not getting warm at all. Maybe slightly, but it's not getting hot. And I can run this for quite some time. So this would be kind of similar to what might happen. Let's say you had a 4-cylinder engine like a DA200 or something like that with twin CDIs. And maybe somehow, for whatever reason, if you had this TVS circuit in there on both of them, and one of the CDIs just, internally shorts like this, the engine would probably still keep running on the other CDI and the other 2 good cylinders, and you certainly notice it. Your engine would be running rough. You'd come in for a landing, and this would let you have complete control of everything because it's not going to allow any high voltage at all and get back to the receiver. Everything's going to be absolutely fine. Okay, so all it takes is that tiny little thing, which can be embedded inside basically into the wiring harness near the CDI, with some heat shrink tubing to just cover it all up. And I'm looking into making these available if people really want them. I've been asked by a small number of people about it, and if it turns out that people need it, well, we can do something there. And we'll figure out what that's gonna look like in a short time. So let's just turn the IBEC off for just a moment. Disconnect it over here. Okay, kind of show you that it goes back to normal. IBEC's back on. Everything's snapping away like normal, just as if thing never shorted, so we didn't even hurt the CDI by doing that. All we did was avoid the spark from ever getting out to the plug, and everything's still just great. Let's take a look at the data monitor. I don't know if that's going to be readable or not. I'll try turning the light on. Light's been off just to make it easier to see the spark. Now let's just see if it's even possible to, there we go, I think you can read that. That's just the voltage. There's the first receiver, no fades. That's no receiver because it's just a two receiver unit. That's the other receiver, no fades. That's nothing there. And no frame losses. No holds. Back to 6.2 volts. So that's it. I think that probably demonstrates everything pretty effectively. And if anybody's got any questions about this, I'd be very happy to answer them. Thanks very much.